Okay, let's let complete the square flex its muscles. So what do I mean there? I mean the process to complete the square for factoring and solving quadratics and also looking at the vertex. So what I'm going to do, I'm going to write the standard form equation. Ax squared plus bx plus c. I'm going to go ahead and set it equal to 0. Right, the purpose of this is going to be to examine exactly what we do to solve quadratic equations. And what we're going to end up with is a lovely formula that works for all quadratic equations. Right, hopefully that's some good news for you. Okay, so what I'm going to do first, in order to complete the square, of course, we must have a quadratic coefficient of 1. So in order to do that, I've got to divide the entire equation by a. Right, and of course I could say 0 divided by a, but it's just going to be a, right? Okay, so what does that mean? I've got x squared plus b divided by a, x plus c divided by a. All of that still set equal to 0, right? Okay, that's wonderful. Now that I've got the quadratic coefficient equal to 1, what I'm going to do is the standard process, which is, of course, b over 2 squared. That's going to be the number, the magic number, that makes this complete the square, in essence. So let's try that. But first, we're going to move this c over a to the right. So we'll do that by subtraction, minus c over a, minus c over a. We'll be left with something quite nice. X squared plus b over a x equals negative c over a. Okay, right. Cheerio. Now we're ready. So b over 2 in this case. Well, what is in place of the b term is actually b divided by a. So what that means is, if this is our b term, then b divided by 2 is going to be b over a divided by 2, which is b over 2a. And of course, remember, we have to square it. So we're going to eventually square this, and it's going to be b squared over 4a squared. Right? Make sure I don't forget that part. Square the top, b squared. Square the bottom, 4a squared. Okay, focus a bit. So now that we've got the logic behind what number we're going to add, I'm going to go on and write what that would be. So from this step, x squared plus b over a, x plus, right, that number turned out to be b squared over 4a squared, okay, and that's all equal to, of course, what's on this side is negative c over a, and of course if we add it to one side, you've got to add it to both, so that's plus, there's a plus sign there, hopefully I don't screw that up, b squared over 4a squared. Okay, so lovely, isn't it? What we've got to think about now is the whole point of this was to complete the square so that we could get into a vertex form, or essentially solve for x. So I'm going to need a new page for that, so we're going to copy all that information over to this side. Hopefully you're following along there. We've got x squared plus b over a, x plus b squared over 4a squared equals b squared over 4a squared minus c divided by a. Remember, because the c over a was negative. Okay, so that's where we're at. And I was like, well, what does this, how does this make sense? I'm not sure I'm following you, sir. Again, stay with me and see if you can figure out what's happening. So these are the numbers. Remember, these are the numbers that complete the square. So we'll draw a square around them. And then what we're going to do, we're able to say, okay, automatically this becomes x plus something squared. All right, this left side, I'm not going to touch that. I've got b squared over 4a squared minus c over a. Okay, so essentially, if you remember from class, to go from this step to this step, you simply take the square root of this. So how do we find the square root of b squared over 4a squared. Recall that's the same as the square root of b squared over the square root of 4a squared, which of course is going to be b over 2a. Looks familiar, doesn't it? So I've got b divided by 2a. Righto, righto. Alright, so this is the stage now that lets us solve, at least in an effort to get x by itself, or solve for x, get rid of the squared part, right? So we're going to take the square root of both sides. Okay? So I'd be left with, on this side, x plus b over 2a, and the parentheses is really not necessary, right, equals, anytime we take the square root of both sides, we've got to do this mess, plus and minus the square root of b squared over 4a squared minus c over a. Alright, now I'm going to engage some of your middle school algebra and fractions, right, because this doesn't really seem to be making anything logical or simple, right? What we're going to end up doing, before I take care of this ugly bit, is solving for x. And of course that step is pretty simple. We're going to subtract negative b over 2a. We're going to subtract negative b over 2a. And that's going to give us x equals negative b over 2a plus and minus square root of b squared over 4a squared minus c over a. Okay, what is this telling us? This is saying I can solve any quadratic equation that starts out like so if I simply memorize this hideous formula. And I don't mean that lightly. That one is quite hideous. But there are some tricks and simplifications we're going to do so that this becomes much easier to remember and actually fits into a song. So what we've got to do, this radicand is pretty ugly. So in order to cure that, what I'm going to do, oh, too much light there, okay. What I'm going to do is try and combine these two fractions. And if you remember anything from middle school, to combine fractions, to add or subtract, you've got to have a common denominator. So, what is the denominator? It's the 4a squared. This denominator is a. So what I've got to do is make them in common. So, what I can simply do is multiply by 4a on the bottom, because that will make that 4a squared. And anything I do to the bottom must be done to the top. So we're going to say times 4a there. So that the net effect of this bit here, I'm multiplying by 1. I'm not changing anything. So let's see what that gives us. X equals negative b over 2a plus and minus the square root of. Okay, what have we got now inside the radical? Now that these are the common, I can simply write it as b squared minus, what's 4 times a times c? Well, of course, it's just 4ac. And then all of that's over 4a squared. Okay? Hopefully you remember that the radical can be simplified or spread out into two radicals. So b squared minus 4ac all over the square root of 4a squared. Okay, get some focus in there. So just this part here is equivalent to these two radicals. And that means, what does that mean? Is there anything I can do with this? So we have x equals negative b over 2a plus and minus. Okay, that part is stuck. I am stuck with that. B squared minus 4ac. But I know the square root of 4, it's 2. I know the square root of a squared, it's a. What do you notice? But that these have a common denominator, so I can rewrite that as one large fraction. I can add the 2 and subtract the 2 and get this lovely bit of maths here. All over 2a. All over 2a. My friends, I have just derived what we like to call, actually it's the name of it, the quadratic formula. The quadratic formula is called the quadratic formula because it is the formula to solve all quadratic equations. So, a, b, and c are the numbers that come from the standard form version, right, as we mentioned at the very beginning, a, b, and c. So essentially, if you remember the quadratic formula, all you do is plug A, B, and C into this template or formula, and it will give you the two solutions for that equation. Okay, why show you this? First, it always works. It's called the quadratic formula for that reason. Second of all, it will help show us a new method for finding the vertex. So what I want to do is write x equals negative b, and I'm going to write it separately for the time being, over the square root of b squared minus 4ac all over 2a. All right, so what I want to do, I want to think about something. Why is this written separately? Plus and minus. Well, that means I can add the same number or subtract the same number. So in order to do that, that means this must be my anchor, my reference point, or, as we've learned in class, the middle. Essentially what I'm saying is that if this number turned out to be 3, then whatever this is, for example, we're taking negative 1 plus 3 and negative 1 minus 3. That's going to produce a 2 and a negative 4. What do you know to be the middle number between 2 and negative 4? Of course, it's negative 1. So what we've just done is discovered a method for finding the axis of symmetry. X equals negative b divided by 2a. And if it finds the axis of symmetry, then does it not also find the x-coordinate of the vertex? All right, here's what I mean in pictures. Here's what I'll try to show. So if we know there's our parabola, right? If this is negative b over 2a something, then this part is negative b over 2a plus, we'll call this bit up here, this bit, we'll call this big R, okay? So that would be plus R, and this would be negative b over 2a subtract R. You see, for it to be in the middle, does it not have to be the same distance from both of the ends? So if it's R from here to here, then it's R from here to here, meaning it's in the middle. So, all of that theory to say this. The vertex can be found by negative b over 2a, and then if we know the x-coordinate, we simply plug it in to find the y. So f of negative b over 2a, right? So, to see this in action, let's take a look at a particular example. 4x squared plus 16x minus 3. All right? No more of this factor stuff, even though we could try. We're going to skip right to negative b divided by 2a. That's going to be negative. The b is 16. So we've got maybe a good trick here is to go ahead and label those. Negative 16 over 2 times 4. So that becomes negative 16 over 8. That means the vertex occurs at negative 2 something. How do we find the something? Well, we're going to plug it in. 4 times negative 2 squared plus 16 times negative 2 minus 3. So, we're going to do that small bit of calculation. That's going to be 4 times 4, 16, negative 16 minus 3, negative 19. So, what I've done is maybe give you a streamlined version to find the vertex. All of this is related to quadratics. All of it stems from the derivation of the quadratic formula. And it will all help each of us in our attempt to solve problems involving quadratic functions. Come with questions, not blank pages.